lecture series on artificial intelligence and machine learning. In this lecture, we'll see the machine learning paradigms. Machine learning paradigms refer to the different approaches or strategies used to train algorithms to recognize patterns, make predictions, and improve their performance over time. These paradigms are generally categorized based on the type of learning involved and the nature of the data available for training. So, the primary machine learning paradigms are supervised learning, unsupervised learning, and reinforcement learning. The supervised learning, in this paradigm, the model is trained using a labeled data set where each input comes with a known correct output. The model learns to map input to output, making it useful for tasks like classification and regression. It is widely used in problems such as spam detection or not, image recognition, and sales forecasting. Unsupervised learning. Here, the model is provided with the data that is not labeled, meaning the outputs are unknown. The goal is to identify underlying patterns or structures in the data, such as grouping similar items together, that we can call it as clustering, or reducing the data dimensionality. This we are calling it as the dimensionality reduction. Applications include customer segmentation and anomaly detection. And reinforcement learning, in this learning, an agent learns to make decisions by interacting with its environment. The agent receives feedback in the form of rewards or penalties based on its actions. This paradigm is widely used in robotics, game playing like AlphaGo, chess, etc., and autonomous vehicles. Each of these paradigms addresses different types of data and problem solving techniques, and the choice of paradigm depends on the specific task, data availability, and learning goals. First, we will deeply discuss about supervised learning. The supervised learning is a fundamental type of machine learning in which a model is trained on a labeled data set. This means each training example include both input that data that we can call it as features and the correct output label. This is input, this is a label. This model job is to learn a relationship or mapping from these inputs to the respective outputs. For example, in a student grades prediction task, input might include the number of study hours and attendance percentage, while the output would be what would be the output? Output would be the final grade. The model uses this training data to recognize patterns and trends, allowing it to make informed predictions on future unseen data. Next, so here this is the input samples. This is the labels. We are training this samples. So the goal of the supervised learning is to develop a model that can accurately predict the output for new inputs based on what it has learned from the training data set. This mapping allows the system to apply its knowledge beyond the data it was initially shown, which is essential in real world scenarios where the model will encounter unfamiliar situations. The success of this approach relies on how well the model can generalize from the training examples to make accurate predictions on new data. So, what is called a supervised learning here? The term supervised refers to the model is trained under guidance, just like a student being taught by a teacher. During training, the model shown the correct outputs along with the inputs. So, here this is the training phase. Tractor, car, bike, and a cycle. It may say that it is a training phase. So it can say that the model shown the correct outputs along with the inputs, allowing it to adjust and learn by comparing its predictions to the actual answers. This supervision helps the model improve over time by reducing the difference between its predictions and the true value, often through techniques like error correction and optimization. So, once if it has been trained, I am giving some other car and I'm asking the system what type of the output would be. After taking enough training, it can immediately, the system can immediately says that this is the car. Next, you should know some basics about some of the terminologies. The labeled data set. So, in the supervised learning requires the labeled data set for training. In the sense, this labeled data set is the heart of supervised learning. Heart of supervised learning. Each data point must be a known output, which serves as the correct answer during training. This helps the model understand the relationship between the input features and their corresponding outputs. Without these labels, the model would have no way of knowing if its predictions are correct, making learning impossible. A well prepared labeled data set enables the model to learn effectively and make reliable predictions. Next phase is the training function or model. The model is trained under supervision to minimize the error between predicted and actual outputs. How the training process involves feeding the model input output pairs repeatedly so it can identify patterns and relationships. The model makes predictions and then compares them to the true outputs. The difference, known as the error or loss, is measured and used to update the model's internal parameters. This process continues iteratively until the model's predictions are close to the actual values, minimizing the error and improving accuracy. Next, predicting the new inputs. After training, the model generalizes from the dataset to make predictions on the new samples. Once it has been trained, the model is tested on new, unseen input to evaluate how well it has learned. The ability to generalize, meaning to apply what it has learned from the training data to new situations, and it may be critical sometimes. A well trained model should be able to predict the output for new data points accurately, even if it has not seen those exact input before. This generalization is what makes supervised learning valuable for real world applications. And say, for example, if you are taking the predicting house prices, a common example of supervised learning is predicting house prices based on various features like square footage, number of bedrooms, location, and age of the house. This is a regression problem where the output is continuous numeric value. The model learns from past examples where both house features and their actual prices are known. Once trained, it can estimate the prices of new house by analyzing its future and comparing them to similar pattern seen in the training data sets. And there are two types of supervised learning. This we have seen it in the previous slides, previous lectures. There are two main types. What are they? Classification and regression. In classification, the model predicts a discrete category or label, such as whether an email is spam or not. In the regression, the model predicts a continuous numerical value such as house prices or temperature. Both types rely on labeled data and follow the same core principles of supervised learning but are applied based on the nature of the output. And see here, and here this is the, as I've said previously, in the supervised learning, this is the input training data set. We are training by giving, these are all the input features, and we are corresponding labels we are giving. By giving the labels and the feature, input feature, we are training the system. And what is the main object? And once, if it is unknown car, here we have not already trained, but the car type of model that has been trained, the system immediately classifies that it as a car. If the picture is coming like this, or if you are showing the data like this, it is immediately saying that it is a car. What is the main goal? The main goal of developing a machine learning model is to create a system that can learn from data set where each example is composed of both input, what it has got it, both input data and corresponding output. This we are calling it as the label. The data set acts as the foundation for training the model, helping it to understand the relationship between input features and output value. Through this learning process, the model adjusts its internal parameters. So it will be adjusting the internal parameter to minimize the difference between its predictions and the actual outputs, allowing it to generalize the patterns in the data. The objective is to build a model that can recognize these patterns and use them to make predictions for new unseen examples in the future scenarios. So once if it has been trained, it can immediately classify it as what it can say. It can say it as a car. So after once the model has been adequately trained on the data set, it should be capable of making predictions on new unseen data. This is the new, and this data is the new unseen input. These are inputs that were not part of the original training data. The model should be able to apply what it has learned from the training examples to generate predicted outputs. For instance, if the model was trained to predict house prices based on the features like size, location, and the number of bedrooms, it should be able to predict the price of new house based on the features. Even though it has never encountered that particular house before, uh, the ability to generalize and produce accurate predictions on new data is what makes the model valuable in real world applications. And the classifications overview, if you are looking into, if the output values of a function are limited to specific distinct categories, the task is referred to as the classification. So classification means what? Distinct categories. The task is referred to as the classification. Classification is a type of supervised learning, as I've said before, in which the model's goal is to assign each input data point to one of the several predicted categories or labels. Unlike regression tasks, where the output is continuous, the output is a classification is discrete, meaning it to belong to a specific class or category. The categories are predetermined during the training phase, and the model learns how map input and based on the provided label data sets. So in this example, so the this example how this model has been able to work in the sense, here we have trained a tractor, car, bike, and cycles. Enough trainings have been given, but instead of giving either of the four categories, here I am giving this picture. This is all you know, that the human being knows that it is a bus, but without that is training I'm giving, but we have not trained before, so it will gives us only the what it will give. It will gives us only the output as either bike or car. So the model can only produce the output from the set of predefined categories labeled in the data sets. So if you want to classify the object into car or bike categories, even if the input is a bus, the model will still choose one of these two labels, either car or bus or bike, either car or bike, because those are only classes it has learned. This model, as the computer has learned only these model. The model cannot predict the outside the predefined label. This is the outside the predefined label. This is a bus, regardless of the input. So it will gives us the output it has. It will classify it will as a car. And another one more example, a group of lines I have trained and these I have trained. This is the data set. We have trained enough number of data we have given for training, and I am giving one input is identify this animal. So my classifier will immediately says that it is a deer. One type. It is not exactly like this, but the category is similar to B. It's just correlating this feature, so it can immediately says that it is a deer. The classification will do the functions like this. So in regression, if you are taking, if the output values of a function are continuous and can take any real number with a given range. So unlike the classification where the output is discrete or belongs to predefined categories, regression deals with predicting continuous numerical value. Yesterday one data, one value, tomorrow, today one value, and tomorrow it may be increasing. It is like a gold. These values can range from negative to positive infinity and may include decimal points, making regression suitable for problem where price measurements or amounts are required. In regression, the model is trained to predict numerical output based on the pattern it finds in the input features and allowing it to generate continuous predictions rather than just assigning it the categories. And how the model works, you know that. So in the regression, based on the food sizes, room sizes, and the age of the house, it will be giving us the model once it has been trained. Say, for example, in this case, predicting the house prices, as I've said already, estimating the price of the house based on the features such as its size, location, number of bedrooms, and age. The output is that is price is a continuous value. Next, coming into the that is classification regression combinedly. Classification and regression, as I've said, the summary of this supervised classification and regression are both types of supervised. Both are the types of supervised learning where the model learns from labeled data. In these tasks, the model's decisions are based on ground truth. This we can call it as very important point. Ground truth labels or values in the dataset which are used to train the model. These labels guide the learning process, helping the model to understand the relationship between inputs and outputs. The goal of supervised learning is to improve the model's ability to make accurate predictions on new unseen data. Next, ground truth means what? Labels, values. In the supervised learning, the model depends on ground truth labels or values. It means that are provided in the training data sets. These labels are correct answers and help the model learn how to map input to the correct output. During the training process, the model compares its predictions to actual ground truth and adjusts itself to minimize the error. This guidance helps the model understand the patterns within the data, improving its accuracy over time. Next, learning experience, learning from experience in supervised learning. The model is supervised in supervised learning. How it will learn? From the experience, which refers to the process of improving its predictions based on past data. As the model seems more example during training, it gradually adjusts its parameter to better predict output. This learning process enables the model to generalize from the dataset, allowing it to make accurate predictions on new unseen inputs. The experience gained from the training with the ground truth label is crucial for the model success in real world applications. And the classification, you know that model predicts the discrete categories based on input data. For example, it might classify emails as spam or not spam. The output is a label from predefined set of categories. The model is trained to identify patterns in the data that lead to correct classification and assigns new input to the appropriate category. And classification tasks are often used in the text classification, image recognition, and medical diagnosis. Finally, regression, it means what? The model predicts the continuous numerical value based on these input features. For example, predicting the price of house based on the size, location, number of rooms is a regression task. The output is a real number, not a category, either this or not. Regression models are used when prices precise numerical predictions are required, such as in financial forecasting, weather prediction, and also sales estimation. So these are all the summary about the supervised learning. Hope everyone understood the basic concepts of the supervised learning. The remaining things we'll discuss in the next lecture. Thank you.